everybody. Welcome to afternoon session. Windows Azure table storage. Was they good for? My name's Steve. I work for Vista Entertainment Solutions. Hopefully that looks a little bit familiar. Otherwise, my marketing manager is going to be terribly upset because we're sponsoring TechEd this year. One of the most important parts, which is the coffee cart over in the hub. Vista is a New Zealand company. We do software solutions for the cinema exhibition industry. In other words, we help people sell you movie tickets and popcorn. We're quite successful. People are using our software in about 58 countries around the world. I personally work, I'm the development team lead for our SaaS solution, which is aimed at the independent cinema market, and that all runs on Azure. But I'm here to talk to you today not about the company I work for, but Azure Table Storage, or ATS as I'm going to call it for the rest of the afternoon, because frankly that's a bit of a mouthful. Because a few years ago I got to work on a Greenfields project, and it was decided it was going to run on Azure, and we're going to store all of the data in ATS. Now that sounds like a great idea, but all of the guys on that project, myself included, we're all relational guys. You know, we've used SQL Server for years, and so we made some mistakes along the way, and we learned a few things. So I'm kind of hoping out of this session that you guys will take away, learn from some of the mistakes that we made, and maybe be a little bit better prepared if you're going to start trying to deploy a solution that uses ATS. So this is what I'm going to talk about today. I'm going to start off by talking about what I think Azure is good at. Then I'm going to spend a little bit of time about talking about what ATS is not so good at, because it's very important to know what sort of limitations you might hit when you're designing your solution. Then I'm going to talk about how I design tables to go into ATS. And at the end, I've got a little bit to say about backups and emulators. So we'll start with what ATS is good at. When Microsoft were designing ATS, I think pretty much where they started is they needed to handle web scale data. On the web, you've got lots of people doing lots of stuff, and when they do stuff, that creates data, and there's a lot of that. So ATS is not really targeted at your hobby blog that gets 26 visits a week. You can use it for that, and there's a couple of reasons why you might want to, but you're not really the target market for ATS. How much data can it handle? Any one storage account in Azure Storage can handle 200 terabytes of data. That's quite a lot, particularly when you compare it to the other options you've got in Azure. Windows Azure SQL Database, or SQL Azure, depending on how old school you are, can handle 150 gig. So that's a reasonable difference in size. If you are willing to stick together multiple storage accounts, Microsoft have pricing plans where they will quite happily charge you for 9,000 terabytes of data. Yeah, I hope you've got a healthy credit card if you're going to be using that much. Having all the data in the world is absolutely useless if you can't get it out again. So ATS is designed to handle web scale transactions. It can handle quite a few. Each storage account can handle 20,000 transactions a second, which that's a lot. But that's not the only story. Each partition inside the account can handle 2,000 transactions per second. So there are smaller breakups of your data within the account that you have to be aware of. It's worth noting that these numbers aren't hard limits. These are targets that the Azure storage team have set themselves for what they want to be able to provide to you. Now, so depending on what you're doing, you may get more or even less than these number of transactions. But these are really good numbers to keep in mind when you're trying to think about what sort of scale your application can handle. Now you might say, hey, look, I can do all of this in SQL Server, and there was actually a really good talk earlier today, I believe it was yesterday, about building out really, really large data sets in on-premise and SQL Azure. And that's true. But that requires some fairly serious SQL chops to be able to do that, and some fairly serious amount of money. So yeah, most people, when starting out with something that's running in Azure, probably don't have those skills. So ATS gives you a much easier and cheaper way to get into it. I think Azure is absolutely cheap, and also think it's relatively cheap. For ATS, for 9.5 cents per gigabyte per month, I think that's pretty good. That's with geo-replicated storage. If you compare that to Windows Azure SQL Database, it's going to run you closer to 10 gig a month. Now, with ATS, it's not just this, the price of your data at rest that you have to pay for. You do have to pay for transactions that you make to your data. But for $1, you get 10 million transactions, and that's quite a few. Or to put that into perspective, for the price difference between ATS and SQL Azure, you could pay for 37 transactions per second for the entire month, every minute of every hour of every day. That'll get you a long way. Another good thing about ATS is you can use it on any development stack, well, nearly any development stack. Underlying it all, it's a REST API. So if your stack can talk to the internet, you can talk to ATS. If you don't want to go to the effort of writing your SDK yourself, out of the box you can get SDKs for all of these platforms. Good thing about these platforms is they're also all open source on GitHub, no less. So if you want to go and see what's running in the code, or if you've got ideas about how to make them better, it is run by Microsoft, but they do quite happily accept pull requests from people. And yeah, you can see exactly what's going on. One of the other highlight features of ATS is that it's schemaless. There's no fixed schema. Every entity that you put in your tables has got to have a partition key, which goes back to those partitions I mentioned earlier, a row key, and a timestamp. Outside of that, go nuts. You can have pretty much anything you like. However, just because you can have whatever you like in a table, it's not necessarily such a great idea. If you're wanting to save on your coding headaches, unless you have a particular requirement like batch transactions, which I'll talk about a little later, you'll find yourself, it'll be much easier to keep entities of one type in any one particular table. You'll probably find people that disagree with me, probably on the internet, but you know, people disagreeing on the internet is not a strange occurrence. The big advantage for doing for this, you might say, then why bother with this schemaless thing if you're just going to keep one type of entity in the table? You know, that's what SQL does. The advantage here is if you've got lots of data, and we're talking lots and lots of data, if you need to add a new property onto the entity that you're using, you don't need to go and run some alter table statement and wait for it to run and lock your data, blah, blah, blah. All you do is go away, take your entity, save it in table storage, and you're away. Your code has to be able to deal with what happens if it loads up an entity that hasn't got that property, but I mean, that's usually fairly trivial to deal with. Now, this is not something that you'll probably be able to sell to your boss, but let's be honest, we're all developers here. Working with new stuff is kind of cool, and NoSQL is still reasonably new sort of thing to deal with, so I think this kind of is a reasonable reason to use it. So that's kind of the good stuff. What to watch out for? What's it not so good at? Now this might seem obvious, as ATS is a NoSQL service, but if, like me, you've been working with relational databases for so long, it's worthwhile reminding yourself that you're not dealing with a relational database here. Part of this comes down to technical differences between working with something like SQL Server and ATS, and part of it is just a mindset thing. There are certain things that we've been trained to do that are no longer relevant with ATS. One big thing that is you have to get used to is you only have one index per table. And this is the partition key and row key combination that I talked about a little earlier. If you're talking about this in SQL Server terms, this is a clustered unique index. So all of your data is stored in partition key and row key order. And just like with SQL, as soon as you start running a query that doesn't hit your index, you're doing a full table scan. And if you're using ATS, you've obviously got a lot of data, so scanning that is likely to be a really, really bad thing to do. So this does mean that if you are designing, one of the most important things that you can do when you're thinking about working in ATS is making sure you've got the right partition key and row key set up for your application. The type of queries that you should be trying to run, the ultimate one that you want to run is where you've got the partition key and you've got the row key, go and get me that bit of data. Another is you've got a partition key and a range of row keys, or greater than and less than, go and get me that data. We only know the partition key, but get me all the data in that partition. Get me everything within this range of partition keys. And, no prizes for guessing, the last one is where you've got a range of partition keys and a range of row keys. That last one is less common, but will come into use a bit later. Now, just because our ad hoc queries that we're doing are slow, doesn't mean that you never want to do them. There's bound to have been a time where if you've spent all this time carefully designing your partition key and row key, and someone will come to you and say, how about this information? Go and find me all the people who like foo. It's like, well, you could say, well, that wasn't, you didn't ask me to design for that. So you can still go and run these queries, and they can be very useful. But I wouldn't make queries like this part of your line of business applications. Because they will take a long time, and yeah, they won't be responsive enough. Now, you might get clever and think, okay, well, I've got this data and I've got a set of partition keys and row keys, and I want to go and get them all at once. So you might write a query that looks a little bit like this. Bad news, this also does a full table scan, which is not what you would expect, but that's just the way it works. So the solution to this is, well, a couple of solutions. The first one is to break this down into individual queries and run them in parallel. So take the first partition key and row key, go and get that, and the other one in parallel, that obviously only works up to a certain point, because depending on the hardware that you're running on, depends on how many queries you can actually realistically run in parallel. So that's probably more up to something where you'd have to profile that and see what's going on. If you do find that you want to do stuff like this reasonably frequently, chances are all this data that you're trying to get is related in some way. So I'd go back and look at your partition key and row key scheme again and see if you can somehow get all of this information with one of those queries that I talked about earlier. Now, regardless of what storage you're using, writing queries against any sort of storage is what's going to kill your performance. With ATS, this is even more so. The storage team reckon that the latency on a call to storage is about 100 milliseconds. Now, I can't count that fast, but when you're talking about the performance of your web server, 100 milliseconds is a reasonably significant amount of time. This is good to think about because if you're trying to design a high-performance web application, you probably know roughly how long your server's got to respond to a call. Call it 400 milliseconds. So if you think you've got 400 milliseconds to do everything that you've got, and so it takes at least 100 milliseconds to make a query to ATS, that's a lot of time gone, so you can really only run a couple of queries, sort of maximum. ATS doesn't, strictly speaking, support transactions. You can't use the distributed transaction coordinator, even though this is a Microsoft technology. It doesn't work with that. It does, however, support batch operations. Batch operations, though, do have a few limitations. The most likely ones that you're going to hit is that everything can only be in the same table. Everything in the batch has to have the same partition key. You can't be dealing with more than 100 entities. And I accidentally went to the next slide. Now, obviously, this can be a bit of a deal breaker. If you're designing a financial application and you need to update lots of stuff all over the place, ATS is probably not for you. And that's fine. There are other options. I just move on. Outside of pure financial applications, though, you might think that you need transactions, but I'd encourage you to take a deep breath, go out, get some fresh air, and think about how much you actually do need transactions. And if you've been to any of the presentations about Azure today, you would have seen Scott Guthrie was talking about queue-centric models and eventual consistency. That's the way that ATS is kind of set up to work. So just stop and have a bit of a think about that. We'll say row. If you're used to SQL, an entity is a row. With ATS, you get good basic support for good basic data types. I'm pretty sure they flew to the moon with less than this. But if you want anything over and above what's here, then you've got some pretty good basic types to work with where you can serialize data. And you've got a string, you can happily store JSON, or if you're a masochist, XML. Or if you want to do something a little faster, there's binary serialized objects as well. There are a few limitations on what you can actually serialize into these. You can't have any more than 64 kilobytes per property, or field, if we're thinking relational terms. Can't have more than 255 properties, and you can't store more than a meg per row or entity. Personally, if you are trying to store more than 1 megabyte worth of data in a row in ATS, it's probably the wrong solution for you. You should probably be looking at something more along the lines of blob storage. It's a much better fit for that size of data. Now, you might be thinking a couple of steps ahead of me and be going, right, well, I can't store all the stuff that I want to store here, but I can do binary serialized objects, and I've got byte arrays. So if I just got a bunch of byte arrays, and I serialized, say, for example, my .NET class, and spread it over a bunch of byte arrays, then I can store whatever the hell I like. And great. Yes, that's true. There are even projects to support that, and that's referred to as using fat entities. Personally, not a big fan for a couple of reasons. One, you completely lose the ability to do those ad hoc queries. Now, like I said, your application's not meant to be using them. You should be using the petition queue. But they are still really, really useful. So that's one of the reasons I don't like that. And the other is, if anyone has ever tried to deserialize a .NET class after the class definition has changed, not a big fan of trying to do that either, particularly when you're working with a platform which actually deals with that sort of stuff really, really nicely. So, forewarned is forearmed. Now, unlike ad hoc queries, where they're supported but they're really slow, aggregate queries are just not supported by ATS at all. You can't sum, you can't count, you can't do anything. If you want to do that sort of stuff, you end up writing something effectively like this. Doing full table scans and all sorts of stuff like that. You can kind of do this, and I'm not going to be talking about this anymore during my presentation, but if you want sort of a good overview of how to do this, there is an excellent Cloud Cover Show presentation on doing scalable counters in Azure, and there's also a blog post from Steve Marks that covers the same ground. I've got references for that at the end of the presentation. Worth a look, just to sort of get an idea about how that stuff works anyway. So, now I'm going to talk about how I design tables. This is not the only way to design tables. This is how I do it. To do so, I'm going to take you through a bit of demonstration. I've got this great business idea, and after I finish going through this, you may realize why I work for somebody else and I'm not a web entrepreneur. So I've got this idea for stevesmoviesite.com. I'm going to get the public to tell me about the movies that they like. I'm going to put some sort of social networking sugar coating over the top of it. But where I'm going to make my money is I'm going to get I'm going to tell businesses they can email people based on the movie genres that they like. And there's a blurb there about how I'm going to sell it to the public. Now, I haven't built this yet, so if anyone wants to pick this up and run with it, all yours, 5% of the revenue to me, all good, come and see me afterwards. So here's a really basic site design. I'm also not a business analyst. So you need to be able to, I want someone to be able to create an account, they need to log on, edit their details, people need to be able to add movies that they like, give it some sort of rating, find friends, comment on their friends' bad movie choices. And that's probably enough to get me started. So just like with a relational database, you sit down and you think about all the data that you need. So for users, I need email addresses, passwords, where they live. Most importantly, like the films they like in the comments. They need a friend list, and I need a list of films that people can say that they like. Now, normally at this point with a relational database, you'd sit down and you'd try and normalize your data and you'd get it into Boyce Cod normal form and everyone would be happy. With ATS, some of those principles are nice, but they pretty much take a back seat to making sure that your queries will run in a performant manner. So this is about getting your partition key and your row key right. So you don't want to duplicate your data too much if you can, but if you end up duplicating it all over the place, don't lose any sleep. So start simply. What data do you need to get a single entity of, and how do you need to get it? In this particular case, we get a user by their email address, because that's how we're going to get people to log in. But when we're getting it by the email addresses, there's sometimes when we just need some of the information, and sometimes we need others. When we're creating an account, we need to make sure it's not already being used, so we really only care about the email address. Does this exist or not? When someone's logging in, we need to know about the take the email address, compare it to take the password, compare it. Is that okay? It's not a lot there. If they're editing the user, we need to get everything. And because I'm kind of already thinking about how my web page is going to look, I'm going to stick their username at the top. So I need that bit of information as well. So for all my entities, when I'm getting a list of these entities, do I need them? How do I need to get lists of these, and do I need them in any particular order? So the top one there, that's sort of my money query. I need to get the people who like a genre of movies within X distance from a point. I don't really care about the order. I'm just going to spam them. Send them promotional emails. But when I'm searching for friends, I'd like to be able to search for them by name and put it in alphabetical order. Films, I need to be able to look them up by title, where a phrase begins with, and show them in alphabetical order. And if there are two movies that happen to have the same name, like The Italian Job, I'll put them in with the most recent release first, the older version, because most people are probably going to like the newer version, taste not taken into account. When you've thought about all the stuff that your system does need, it's worthwhile taking a back seat and say, right, well, that's all kind of cool, but is there anything that my application doesn't need, but would still be kind of cool? I don't, strictly speaking, need to get the list of all the comments against a particular film, but from a sort of my own personal interest perspective, that'd be kind of cool, so I'll put it in here and think about it later. Now, I mentioned the limitations that you require for batch processing. You need to think about that at this point here so that you can make sure you get the right partition key and row key. In this particular situation, if I lose some of this data, it's not the end of the world. I can live with eventual consistency, so I don't need to worry about this in my example. So with the answers to these questions, what do you do? Any combination of data that's unique is a good candidate for you to be your partition key and row key. If you've got candidates for both the partition key and the row key, and you need to list by one of those items, like for example, user ID and org ID, and you need to list by org ID becomes your partition key, user ID becomes your row key, usually. If you find that you've got the same data and the way that you need to get it is, you need to get the same entity, but you need to get it in two different ways that's not compatible, then you are going to end up creating a secondary index table. Now, that's not an official name, that's just what I call them, but it's basically duplicating your data, but creating a different partition key and row key scheme. So, these are the entities and the queries that I would end up creating for my system. Now, I did say that I was going to be getting an email address is unique to a user, but this is not my first rodeo, so I'm not going to try and use the email address as an actual unique identifier for my user. They change all the time, and they're generally just a bit rubbish. So I'm going to generate another unique identifier for my users and make that my partition key. And that's going to be unique. I've got nothing else that I need to be unique, so I'm just going to leave the row key empty, and I've got a bunch of other properties on there, making sure I'm not storing anything like email addresses in plain text, but that's just me being picky. Now, this is some pseudocode about how I would go and get this. Now, this is not going to run in any storage client library that exists. The storage client libraries are great, but they look really ugly when you're trying to show demonstrations, so hopefully anyone who's ever seen SQL will understand what's going on here. So this is my function where I'd go and get the users, where the partition key equals the user ID that's been passed in, and the row key equals empty. Now, something that's quite important here is that even though I've designed my partition scheme such that I know I'm only ever going to have one item in each of my partitions, I could theoretically leave off the row key part of this. From experience, that's a bad idea. Any query that you run against ATS where you're not specifying the partition key and the row key could potentially return you a continuation token. And that's ATS saying, look, thank you, I've received your request. I've processed it as much as I could, but I've not been able to complete it in a timely fashion. So here's your result setback and a continuation token, which will allow you to carry on and get the rest of your data. Now, you would think if you had a partition with exactly one item in it, and you were running a query to get that one item, that would never happen. It does. You can get back a result set from ATS which has a continuation token and exactly 0 items in it. So really good idea. If you do know the partition key and the row key, always use them all the time. A note on the unique identifiers. GUIDs do make really good unique identifiers. This would almost seem self-obvious given that it's right there in the name, globally unique identifier. But all of those of us who have worked with SQL know that whether or not you're using an auto-incrementing ID or a GUID for your unique identifier tends to start holy wars. All of the reasons against not using a GUID in ATS, they're gone. I said that partition key and row key, they're clustered indexes, but we don't have the same write issues that we do in SQL Server. So just use GUIDs. There are a couple of other really good reasons for using GUIDs in ATS. The biggest one is that you take away a point of failure. If you're going to use sequential IDs, you have to store that the next ID to use in some sort of central system which implements locking, be it SQL Server or blob storage or something like that. That creates a bottleneck for your application. Whereas you can create a GUID, you can have 63 web servers and they can all generate IDs and there's no locking, there's no nothing going on there as well, and that's great. Another less important advantage of using GUIDs is it does give your data a reasonably even distribution. So if you want to process parts of your data, you can say process all of my data which starts with 0. And you'll get, give or take, a 16th of your data. And so that way you can evenly split out your workload. Whereas if you use sequential IDs, because the partition keys are strings, you can say, give me everything that starts with 1. It gets you everything which is 1, 10, 11, 12, 100, da, da, da. And if you've got a million items, suddenly your block which starts with 1 includes a million things. Your block which starts with 2 it has about 100,000 and change. So yeah, it's a bit awkward. Now, because I'm no longer using the email address as the unique identifier for my user, I need another table, my secondary index table, so that I can look people up by email address. So here I've made the partition key, the email address, the row key, their hashed password, and I've got the user ID there so I can continue to look up the information. And so this is the first example where I'm repeating information that is on my user entity. This is not evil. I'm not going to relational database hell for this. because I'm living in a NoSQL world. Yay. This table allows me to run two quite good queries. If I'm trying to check to see if an email address exists, I can run a query like this, give them the email address, hash it, go and see if there's any results returned. Now, I'm presuming that my any function here goes away and deals with continuation tokens. So we'll just pretend that that works automatically in my storage client library I'm using here. It also allows me to get the actual user given the password. So given any username and password, hash both of them, go and do a match, see on partition key and row key, see if I get a result. If I do, great, I can go and look up the full user, and that's all good. A slight point on this is that I did say that underlying all of this, ATS is a REST API. If you run a query for a partition key and row key, and ATS finds no match, it will return you a 404 error. You know, that resource doesn't exist. Why is this relevant? Depending on the storage client library that you're using, will depend on whether or not it surfaces that error or not. In earlier versions of the .NET storage client library, you'd go and get an item, and it would chuck an error. And you go, that's not what I was expecting. That's since been improved, and there's flags that you can set to change that behavior. But just depending on the library you're using, bear that in mind. So, for films, this is what I would do. There's no sharp intakes of breath, so that means that I'm guessing no one's too shocked at the fact that I'm repeating genres here rather than keeping them off in a child table. I can get away with this because of the domain that I'm working in here. I can be pretty sure that a film's not going to have 251 genres. Depending on which domain you're working in, that may not be true. The other points to note here, I've got the partition key as the normalized film title. Basically, that's me making the title case insensitive, sort of in a just to uppering it, basically. And because we always get items out of ATS in partition key and then row key order, and I want to get the most recent film first rather than the oldest film first, I kind of have to invert the year of release. So in this particular case, I'm going to take 10,000, subtract off the year of release, and go from there. Now, in approximately 8,000 years, this is going to cease working. Or if there was any movies released, I don't know, 1,500 years, 2,000 years ago, this would also not work. But yet again, because of the domain I'm working in, I'm fairly happy with that. And in 8,000 years, someone else can rewrite this, and it won't be my problem. So if I'm trying to run my query that I was talking about before, where I'm looking for films that start with a particular phrase, this is what my query would look like. So I'd take a film name, like The Italian Job. I'd clean out some invalid characters, make it uppercase. And then I would also find out what the next thing in order would be. So I go from The Italian Job to The Italian Jock, and basically get partition key range. And that will bring me back all the films that start with The Italian Job. Now, one thing that's worth noting is that ATS doesn't do contains. If you want to do where my partition key contains something, ATS just doesn't support that at all. You're basically bringing down all the data and then you're scanning through it, and then you might as well be using something else that does support that better. Now, if you're going to use a natural key, like I was doing just there with the film title, you do need to be a little bit careful with some of the characters that you just can't use. The first block there are the control characters that we all know and love: tab, carriage return, bell. The second one is another set of control characters, which I've never personally seen: vertical tabulation set, partial line up. You would have to think, how on earth would those ever get into my data? Watch out for people copying and pasting from Microsoft Word. That's all I'm going to say. The last set of characters there make a little more sense because we underline this. It is a REST API, and obviously all of those characters have meaning within a URL. So one of the ways that you can get around that is that rather than, if you think that you might have a need for actually have these characters in your partition key or row key is to base 64 encode it, is a really easy way. Slight catch is that by default, base 64 happens to include a slash, so you're better off using URL safe kind of base 64 encoding. There's a lot of flavors of those, pick your poison. Now, something that's not actually mentioned in the documentation is this little guy here. The percentage sign, ATS will quite happily let you save a record which has a percentage sign in the partition key or row key. When it gets a little funky is when you try to get that data back out again. There is the Azure storage team have written a great blog about what you can and can't do with a percentage, and they fixed a few issues. My recommendation is just get rid of it. If you have a percentage, just get rid of it somehow, and then your life will be much, much easier. So here's another entity. This is how a user would save their film review. So I want to list these by user, so like I said, I make the partition key the user ID. I need to make this unique and know which film it is, so I've got my the name of the film, the year of release, and then the boring data that the users care about, but I don't for the purposes of this. Yeah, and so the queries that we'd run to get the films for a user, really easy. Problem is that you can't make a petition too small, but you can make it too big. The bigger your petition gets, the slower it gets to write data to it and query it and all these bad things. So I would say err on the side of making your petitions small rather than making them big. Some people say that you shouldn't waste partitions. Partitions are not a precious resource. You can have as many of them you like. They don't cost you anything. They don't cost Microsoft anything. And in fact, having more partitions gives you Microsoft more options for how they can move your data around. So if you've got a particular petition that is being queried a lot, they can shuffle it around and move it to another server. If you've got a large block of data all in the same partition, they've got to move the whole lot at once. So I would err on the side of making them too small. Another thing is you should design for success. Now, in this particular case, despite the fact that I work for a company that works with cinemas, I don't actually see that many movies. So that structure we work for is great. However, I do work with some people who see a lot of movies. Like, I mean, a lot of movies. So they would end up filling up that, create a lot of data. I would probably be starting to push the size of my petition a little too big for those users. And if they've seen a lot of movies, they're probably the type of people I want on my site anyway, so I really got to make sure the experience is good for them. So I would probably actually end up designing the structure of my table like this. I'd take the film title out of the row key and make it the partition key. And that does mean that I'm probably going to end up with approximately one entity or row per partition, or possibly two if they've probably seen both versions of The Italian Job and probably all 6 Fast and Furious movies. But yeah, I would probably go with, it's the same data, just slightly shuffled around. It does mean that my query for the same user does look a little bit different, but this is a pattern we've already seen a couple of slides earlier. So we take the user ID, find out what the next one's going to be, and do a partition key range, rather than doing a partition key exactly equals. Now, if I'm trying to find my friends, I want to find them by name. In this case, first name and last name. And I also need the user ID in there to make it unique, because I'm pretty sure there's a few Fred Smiths around. And as well as the normalized name information there, I'm also keeping the normally formatted first name and last name in there as well, so that I don't have to go and look up the user again. If I'm trying to get back a list of users, I can hit this one table, one query, all the data I need is there. So what would the query look like? If I'm looking for someone where the first name and last name, I've got a bit of each, I can run a query like this. And hopefully by now you're starting to see a bit of a pattern. Here I take the first name, upper it, clean it, same with the last name, and run ranges on both the partition key and the row key. If we're trying to get a list of my friends, Obviously, we're going to list the friends by the person who's logged in, so it's the user ID. We want this ordered by the person's first name or last name. So that's included in the partition key there for order. And the other user's ID is included in there to make sure that this is unique, just in case I do know 2 Fred Smiths. And yet again, including the first name and the last name of that person, so I don't have to go and look it up again. Now, it's worth noting that this is just a list of people who are my friends. I would also need the inverse of this table to say that I am those people's friends as well, so that they can see me in the list. So I'm taking the same information and duplicating it, creating the inverse. And this is how I would find a list of my friends. This should be looking fairly familiar by now. Now, if I wanted to find a comment on one of the films that I like, this is what I would probably go with. Because I said it would be quite neat to, we can only see the comments for a film that I like, but because I also said that I wanted to be able to see a list of all of the comments about a film by all users, at the start of the partition key there, I put the full name of the normalized name of the film, year of release, user ID. I want these in date order, so I have to include part of the time that the comment was made. And because, yet again, I don't want my partitions getting too big, and you can get a lot of comments in a fairly short period of time, I've included the time up to the number of minutes as part of the partition key, rather than making the whole time part of the row key. And the commenting user ID to keep it nice and unique. And yet again, the name to avoid having to look things up. So this is the money part of the application. This is how do I find these people that like a genre within an area. Now, you may notice that at no point previous to this have I mentioned that ATS does geospatial stuff. It doesn't really, but I've kind of got a fudge to make this work, and I think it's pretty neat doing something that I don't think Microsoft thought it was going to do. So here for this, I'm going to start with the genre because my people who are paying me are going to start with the genre. For latitude and longitude, I really only want to store positive integers. So I'm going to take my latitude or longitude, add a number on it to make sure it's always going to be positive, and then multiply it by some fudge factor so I've got enough decimal places there. To keep things unique, I've got the user ID, and the only thing I really care about the user is the email address, because I'm not going to personalize these emails. I'm just going to send these emails out and leave it at that. Now, one thing that's worth noting here is that I did say that you don't want to make your partition keys too big. And I'm making a big assumption here that the location data I have for a user is pretty accurate. If all I've got from somebody is that they live in Auckland, and I get 200,000 people in Auckland, I'm being optimistic here, suddenly I'm going to get a whole lot of people who are all in the one partition. So if you are going to get very, very rough data, this isn't going to work. If I happen to know someone's postcode, or possibly even better, their actual address, then this works a lot better. So the query that you'd end up running for getting your users by your location. Now this is not actually going to do a radius, but I'm going to run with the fact that the people who are paying me don't really care quite so much about that. I'm just going to do a bounding square. And if you do that, then this becomes really simple. You just end up doing a slightly more long-winded version of the queries that we've already gone over. So there's a whole bunch of, yeah, you can see it there. It's pretty straightforward, I hope. Now, this also doesn't work if you're targeting people in certain parts of Siberia or Tuvalu, because it doesn't work over the 180-degree meridian. But if you're focused on New Zealand, you're all good. Now, I'm not going to talk about this too much, because hopefully if you've been to any of the Azure talks at all here at TechEd, quite a few people here have been talking about queue-centric workloads and eventual consistency. You'll note there, I've got quite a few tables, which include the same user information repeated in all sorts of different places. And heavens above, if someone actually a user goes and updates their name, there's an awful lot of places to go and do it. Now, you're not going to go and do that inline in your web app. You're not going to sit there and wait for all that data to update. you take in that update, you would update it in the places that you absolutely need it updated, which is probably in the core table, and you fire the rest off to a queue and just wait for it to catch up. So yeah, and this is pretty much true not just for ATS, but trying to build any sort of scalable system. Don't do now what you can put off till later. And kind of on a related note, make sure that you can get back to all of your index tables from your base data. Because it's no good if you've got some secondary index table off over here and you go to try and find it to update it, and then suddenly you realize, I can't, it's just going to stay that way. Maybe your application's fine with that, but something to think about. Now, I've been spending an awful lot of time talking about partition keys and row keys and the like, but partitioning is not just about partition keys. As far as performance is concerned, the only two things you need to care about is the partition and the table. Sorry, the partition and the account. The table actually makes no difference at all to your to the amount of throughput that you can get out of your application. It's purely there as a nice sort of management area for developers. So you can say, look, all of my users are over here and all of my films are over here. And that's great. So if you're looking at doing really high performance stuff, so you're trying to get more than those 20,000 transactions per second, then you need to think about how you can maybe split your data up over a couple of storage accounts. So, got a couple of thoughts on backups and emulators. The replicas that you get with ATS are not backups. Hopefully you guys have seen a diagram like this before. When you write something to ATS, you send an update, and it goes and writes it to 3 disks. Great. If you have the geo-redundant storage option turned on, it'll then take those same updates, send it to another data center at the different end of the same country, and it will also write it to 3 disks. And this means that if you have something really mundane, like a hard drive failure, you've still got your data in 5 places. Or if something really, really bad happens and an asteroid falls on the data center, you're still okay. It's going to take you a little while to recover, but you've still got your data. So you might think, great, my data can survive an asteroid. What could possibly go wrong? The biggest risk to your data is actually now you. Because I'm sure no one in this room has ever accidentally run a SQL script against the wrong database, accidentally run against test when it's meant to be against dev, or heavens above, even on live, or ever written any dodgy code which actually accidentally goes and updates things incorrectly. If this happens to you, someone that you've carefully explained how Azure carefully has all these different replicas available will say, well, why don't we just go and get the data back from that? The problem is that your little coding mistake has very quickly been replicated 6 times around the world, and yeah, there's not a lot you can do about that. So this person who is probably in a more senior position in your company will say, right, we need backups. And you'll go, okay, yeah, I did make a pretty bad mistake. We probably need some backups. So what you will do is you'll probably go away and you will take all your data that is in one of your data centers and you'll diligently go through and copy it to some other data center. And you'll copy that every single day. And that'll be great. You'll be all very happy. And then you'll get some more data. And your backup will take a little longer. And then you'll get some more data. And it will take a little longer. And trust me, it doesn't take very long until you have more worker roles running your backup, running 12 hours a day just to do your backups. And that, you really have to ask, is that really worth it for my business? Am I putting so much effort and time and money into creating these backups that aren't even really that good because these aren't transactionally consistent backups? If you have a secondary index table and you're diligently back up the primary table, and then you start backing up the secondary index table, yet you might get a core bit of data updated on your primary table, which goes away and updates some data on your secondary index table, and then you back up this bit and your data's inconsistent, and when you're talking about a backup that's running over 2, 3, 12 hours, the chances of that happening are reasonably high. That doesn't mean to say that this is not, there are projects out there that do this, by the way. You don't need to go away and write this all yourself. These can be very, very useful if you're doing something like you need to refresh your test system from live, because that's always really useful. You need to get some real data to work with. But for actual operational backups, not so good. If you decide that you really still do need backups, I would recommend looking at more sort of a transaction log model, where changes that you make are shipped off somewhere else, and you keep the core data and then a log of the changes, so that if anything does go pear-shaped, you can then go back and restore to a certain point. You don't have to take all that, you don't have to accept that table that you dropped or all that data that you deleted. If you decide that you don't want to go to all that effort, just be careful, please. No amount of crying to Microsoft will get your data back. Fortunately, only in a test system. And then we were actually able to do a backup and get it back, but yeah. Now, when you install the Azure SDK, it installs two emulators. One is the storage emulator, and one is the compute emulator. The storage emulator is backed by SQL Server. Now, table storage is not a relational database, so you can imagine it doesn't really map perfectly to being run in SQL Server. This does mean that there are some differences that you'll observe when you're running against the storage emulator than you get running against the real thing, particularly if you're doing something where you do have different properties on entities within a table. In my opinion, if you are going to develop against ATS, just ignore the storage emulator. Running against the real thing is so cheap that it's really kind of irrelevant. Particularly in a dev environment, you're going to be spending more money on your compute to run your dev and test environment than what you'd be running on what the developers are using to talk to the real storage. Having said that, the compute emulator is still really useful. It saves you all that time where you're waiting for New Zealand's really, really fast internet to send your cloud, your service packages up to your data center. So that's still useful, but yeah, the storage emulator, I'd probably give it a miss from day one. And that's all I've really got to say about that stuff. If you want to know more, I can thoroughly recommend the Azure Storage Team blog. The Azure Storage Team don't blog very often, but when they do, they write a lot, and it's all really good information. So yeah, I would definitely put them into whatever RSS reader you're using these days. If you want to talk to me, I'm going to be hanging around here a bit later, but I'll be heading across the hall to stand outside the Vista coffee stand, if anyone wants to talk to me. I'll also be going to TechFest, but chances are I'm not going to hear you above the music, so yeah, probably not quite so useful. And if you want to find out about scalable counters, then it's Cloud Cover episode 43, Scalable Counters, and you can find that on Channel 9. Now, I haven't seen too many people talking about this, but every Azure session that you go on the draw to win a Sharks with Freaking Lasers t-shirt. You might have seen a few of those floating around. But yeah, make sure you've checked in. And of course, please fill in your evaluation forms. Let me know how I did. This is my first time at TechEd. Please be nice. Just saying. Yeah, and that's it from me. Thank you.